today we are going to do exponents using division. So there's a couple more laws of exponents. And the laws I'm not so married to. I mean, they make sense, but they're a little bit confusing to me. So take a look at the laws on your own. You can see that if you have the same base and you've got different exponents top and bottom, you can basically subtract the exponents, and that's fine. But here's what I would prefer to do. Take a look at this first example. When you look at the example, the question you need to ask yourself is, where are there more x's, top or bottom? And the answer here, it's top. So that's where they have to stay. There's more x's on top by 4. You are subtracting, that is correct. It is true that the denominator would be a 1, so you could always do x to the 4th over 1. I tend to not do that. I would just keep it as x to the 4th. Okay? When you look at the second example, you're going to ask yourself that same question. Well, where are there more y's, top or bottom? And the answer would be on the bottom. So therefore, all the y's have to stay on the bottom. Well, how many more are down there? 3. If there's nothing left in your numerator, here's where you must use a fraction as 1 over y to the 3rd. So if there's more variables on the top, you don't need to worry about having a denominator. But if there's more variables on the bottom, you must always have a numerator. The next thing will be as well, when you ask yourself, where are there more variables, top or bottom, you realize that they're equal. And remember, anything divided by itself is just 1. So whenever the variables are equal, your answer is just going to be 1. A couple of shortcuts, not really shortcuts, but another way to sort of expand this is on that first example. I know that I have 7 x's on my top, and I've got 3 x's on the bottom. Again, you know that anything divided by itself is 1. So x divided by x is 1, this x divided by that x is 1, this x divided by that x is 1, and you're left with x to the 4th on the top. That kind of happens with this next example. When there's 2 y's on top and there's 5 y's on the bottom, y divided by itself is 1, y divided by itself is 1. You're left with 1 on the top because the y's are gone, but the number 1 is there, over y to the 3rd. And then similarly, when you deal with this last example with the z's, let's bring this down, bring this up. When we're dealing with the z's, come on, let's go, here we go. We've got z, 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 z. It's like making me sleepy, ha ha ha. So z, 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 z divided by itself is 1, z divided by itself is 1, and so on and so forth. It's not that it's 0, there's no z's left, but there's 1 left, 1 whole, because anything divided by itself is 1 whole. Let's try a couple of examples on this one. Again, the question is going to be, where are there more top or bottom? So in terms of my b's, ask the question, where are there more top and bottom? In terms of the c's, where are there more top or bottom? I tend to always write my answer in terms of a fraction, at least to begin with, and there are more b's on the top by 3. There are more c's on the top by 3. We don't have a denominator. It's not necessary to include one, and there's your final answer. When you get to the second one, don't forget that you know how to divide or simplify fractions. The fact that we've got this negative 9 over 18, it just simplifies to negative 1/2. Don't forget that. And I want the fraction, not the decimal. But then start asking yourself questions about the exponents. More h's are on the bottom, and there are more on the bottom by 3. In terms of the j's, there's only 1 set of j's on the bottom, so that can't go anywhere. That just stays where it is. And then in terms of the k's, those guys are equal. They tend to cancel. They turn into a 1. So your final answer is negative 1 over 2 h to the 3rd, j to the 3rd. There's no problem with having an answer look like this. If you don't want the negative 1 on top, you can just do negative 1 over 2h3, j3. Doesn't really matter how you write your answer. Let's take a look at the next example. In this case, you've got to simplify some stuff on the bottom because you're not completely simplified yet, as well as on the top, I should say. On the top, I've got 3 times 2, which is just 6, In terms of my a's, I've got 5a's and 4a's, or a to the ninth. On the bottom, you actually have two parentheses that both have 6a cubed in them. So the bottom really simplifies to 36a to the sixth. Then you have to do your simplifying. 6 divided by 36, when you simplify it, is 1 over 6, and there's more a's on top by 3. Final answer, 1a cubed over 6, and it's no problem if you want to drop the 1 here because you do have something in your numerator, and a cubed over 6 is acceptable as well. Let me slide this if I can over here. Okay, so for this next one, I'm going to write this out, and we've got on the top, we've got two parentheses, so we've got 4xy squared twice, so 4xy squared, 4x cubed, sorry, and then 4x cubed y squared. In the denominator, we've got 3, and it's 2xy cubed, 2xy cubed, 2xy cubed. If we simplify the numerator, 4 times 4 is 16, x cubed and x cubed, x6, y squared, y4. In the denominator, 2 times 2 is 4 times 2 more is 8. X, and x, remember those are all exponents of 1s. So x to the third, and y3, y3 is y9. You need to simplify this. 16 over 8 simplifies to 2 wholes. So I'm going to give myself a fraction just in case. I've got 2 over 1, the one I'm not including. There are more x's on top. That's where they stay by 3. There are more y's on the bottom. That's where they stay by 5. And that should be enough to get you through your homework. Okay, see ya.